Hi, I'm Andrea and welcome to Productive C#. In this video, I want to talk about the extensible fixed statement feature introduced in C# 7.3. Let me run this console application so that I can show you what it does. This application is printing a pattern of colors as a console application. I have a class picture that contains a read-only collection of colors. Then I have a height and width property. I initialize the colors in the construction of the picture. I have the ability to select a particular row. Then I have the ability to print basically what's it's stored in the colors buffer. So basically the color buffer contains the colors of the entire window, and then print actually use the console foreground color property to set the color and then print it to the screen. I want to get in a second at this method here. Let's have a look at the program main. So I'm using unsafe here, and the reason is because I'm using the fixed statement. So what I do is I create a picture, then for each row I call the drawRow method, and then I print the picture. The drawRow method uses the fixed statement to get a pointer to a particular row inside a picture, and specifically is getting a pointer to a location of the where the selected row starts. This means that using a fixed statement, I can pretty much do everything I want on that location of memory using pointers. As you can see here, I'm using pointer arithmetics. As well here, I'm trying to access the element of a pointer. It doesn't particularly matter what I'm doing inside here and this particular code. What really matters is that I'm using a fixed statement using a particular type. This is not possible before C# 7.3 because you can use the fixed statement only on arrays, on strings, on fixed size buffers, or using any unmanaged variables like primitive types, for example, or enumerators. Here instead I'm using a particular type that I defined inside a fixed statement, and this is basically where these features comes in. It allows you to, by defining a simple method called getPinableReference, gives you the ability to use any type inside a fixed statement. This method must have a particular signature. It must return a ref type to an unmanaged type. Right? So as you can see here, this method is returning a reference to a console color. Console color is an enumerator, is an unmanaged type, so you can do that. And basically what I'm doing here inside the code, I'm returning a reference to the location in colors where the row starts. That is the selected row by width. Okay, so this method here enables drawRow to use a fixed statement using the picture. If I remove this code here, you will get a compiler error, as you can see, and saying that the given expression cannot be used in a fixed statement. So it's very important in order to be able to use any type in an unsafe context to define this method here. Okay, this is obviously a very simple example just for demonstration purposes. It's very unlikely that you're going to need to define your own getPinableReference, and it's mostly useful when you want to return a reference to unmanaged data, or like data that is being created in an unmanaged context. So in this case, I'm just returning a reference to an array of colors. But it's important to know that this array was read-only, but it doesn't really matter because I'm returning a pointer and I'm doing all the operations in an unsafe context. So it doesn't really matter that this is marked as read-only because we are in an unsafe context when we use it here inside a fixed context. Okay. The interesting thing is that some types in the .NET framework, like span of T, that has been introduced with .NET Core 2.0, now supports using fixed statements, and then you can manipulate a span inside a fixed statement. If you go to GitHub, you can see an example of the implementation of get pinnable reference in span. I don't get into the details of this because it's quite complicated under the covers, and it's really not that particularly useful for you to know. The most important things for you is to know that Spanty support pinning using a fixed statement, and other types in the future might also support it inside .NET. And if you want, you can also add the support yourself in your own types. And this is pretty much what this feature is about. It allows you to provide fixed statement support for any type as far as you implement the get pinnable reference method. And that's it. Thank you very much for watching.